This conference will now be recorded.
Okay, perfect. So it's 11 o'clock here on the West Coast. I want to welcome everybody from wherever you're joining for our webinar today, Fast and Easy Cluster Computing with Apache Spark, being presented by our expert in this area, Adam Brandel. My name is Ben Sanroman. I am the CEO of Endpoint Learning and want to thank all of you for taking the time to spend part of your morning and afternoon and learn a little bit more about Apache Spark. Obviously there's a lot going on in the world of big data, machine learning, data science, and at the core of that is Apache Spark. So I think in terms of a lot of the training and initiatives that we're focused on, we felt that this was a great opportunity to focus on cluster computing with Apache Spark. Before we get started and before I turn it over to Adam, for those of you who are not familiar with Endpoint, just wanted to point out some of the areas of expertise that we have. Obviously, data science, machine learning, et cetera, is definitely one of the areas that we've focused on and see as a potential as a huge growth area for us in the new year. We'll be releasing a whole set of new curriculum in 2019, so please be on the lookout for that. But in addition to that, across the organization, we provide learning services on a number of key areas for most organizations in the enterprise. So if there's anything that we can be of assistance with in the future, please feel free to reach out to our team. We'll be more than happy to help out. And this is also just part of one of a set of webinars that we'll be releasing over the next several months. Adam has put together a set of titles that I think will be interesting for anyone in this space. In addition to that, we also have webinars in other areas such as design thinking, leadership, etc. So please be on the lookout for any information or invitations from our team for those webinars. You'll also receive information on some of those sessions at the completion of today's session. The one that we have coming up next week is actually building emotional intelligence across your organization. That'll be presented by Conrad Moore, who's the VP of Learning and Development for Endpoint. Also another topic that we see a lot of interest in regards to our enterprise clients. With that said, I'm going to go ahead and turn this presentation over to Adam to get started. Very excited to have him here. But with that said, I'm going to go ahead and send this over to you, Adam, for you to go ahead and kick things off.
Great, thank you for the intro. Let me get my screen share running. Hopefully everybody can hear me. And if Ben, if there's any issues with the audio at any time, just pop me a message here in the chat, and we'll hopefully get that sorted out. Let's get my screen running.
Perfect.
Okay, so my name is Adam Brandel, and I'll be talking today a little bit about fast and easy cluster computing with Apache Spark. So, we have about an hour together, so of course we're not going to be getting into deep down into the guts of really advanced use cases with Spark. This is kind of an overview, but it will be a technical overview. So I'm going to try and give you some insights into everything from what Spark is about, how you can work with it. We're also going to run some real code. Well, you may not be running it, but I'll be running it, and you'll be able to see it on my screen here. So Apache Spark is a Apache project. It's been around for almost 10 years now, not quite. It's hard to imagine. And it's all about scaling out your compute across lots of machines. When we talk about cluster computing, the whole issue is, what do I do when I have a problem that I can't run fast enough on a single machine, right? So this is kind of a problem that's been around for a really long time, this question of scaling out as opposed to scaling up. And Spark is one of the most successful modern technologies for doing that, mainly because of the ease of use, right? So, the actual transistors in the machines themselves, they can only do so much compute, and they kind of do what they do. And then at the software level, the question is, how do we make that easy for normal humans to take normal business workloads and get them to actually scale out efficiently so we can take advantage of all these transistors, all this silicon. So, okay, so the things we're going to look at today, we're going to take a quick look at the background and architecture or what Spark is and sort of at a very high level how it works. Querying data with data frame, data set, and SQL. So one of the great things about modern Spark is that your traditional business analytics workloads where you're doing analytical queries, or your ETL workloads where you're reading data, transforming it in some way, and sending it somewhere else are really, really easy to use as long as you kind of operate Spark the right way. So if you've used Spark, or if you used Spark in the past, or you haven't looked at it in 3, 4, 5, 6 years, it may kind of blow your mind, because in the very early days of Spark, the tool was able to do fast computation. It was famous for being quick, but it wasn't very easy to use. You had to be pretty sophisticated in the kind of code you were writing. And it was pretty tricky for normal humans to actually work it. That's all gone away. So I think what you'll see today will be a lot more straightforward. We'll also have a very brief introduction to a couple of the other common workloads that people operate with Spark, and that's machine learning and streaming. You'll notice on my screen that I'm running here in a notebook. This notebook happens to be a Databricks notebook. Databricks is a cloud computing company. Databricks itself, this particular version I'm using is free. Their principal offerings are kind of an enterprise SaaS offering for operating Spark. And we're not going to be talking about that too much today, but the notebook model for exploring and learning and experimenting with Spark is really, really handy. So right here on the screen, I've got a list of some free and open source notebooks. If you're coming from the machine learning side, you're probably used to Jupyter notebooks for doing some of your machine learning, or MATLAB notebooks. If you're coming from the data side, you may not be used to this workflow, and that's fine. You don't have to use it at all, but it's really handy for experimenting. So a few of the open source tools that you can use with Spark to get this nice graphical notebook experience are Apache Zeppelin, Jupyter, a project called Hue that was originally from Cloudera. I guess it still sort of is connected to Cloudera, but it's free and open source. And another one called Spark Notebooks. That one's pretty hard to forget. And there's a couple other ones kicking around. A tiny bit about me. I've got my LinkedIn and my email address on the screen here. You're welcome to reach out to me. I've been working with all sorts of areas within the technology stack for about 20 years, and it's kind of come full circle. My first job in tech was data and machine learning and analytics for fraud scoring in using neural nets in kind of a primitive 90s way, and worked on all kinds of other stuff. And nowadays, interestingly, we're kind of back to data and analytics and predictive modeling and neural nets, which is kind of interesting. I travel around the world and work with companies on their Spark projects. I also teach classes on Spark, and I actually read every single commit to the Spark code base. Not necessarily every single line of code, but I actually look at every single commit. So I really try to keep track of what's going on there technically. So let's dive right in here.
Hey, Adam,
yeah.
one quick. Can you maximize your this screen that you're on right now? Just so.
Oh, absolutely. Yeah, so I can't see what it looks like on the other end, so I can't really tell how it's scaling. This gives you a bigger window. I'm not sure if the text is any easier to read.
That looks great. Perfect. Thank you.
Cool. All right, so yeah, this is a data processing tool. So let's go and play around with some data and kind of see what this looks like. Right now, I have a Spark machine set up. It's running actually in Amazon in EC2. Doesn't really matter. You can download Spark for free and run it on your laptop. You don't need Amazon. But I do have it running in Amazon, and I also have some data in Amazon S3, some data sets we're going to play with. And this first one is a set of Amazon reviews. So I'm going to attach my notebook to the actual Spark cluster here. And you can see I've got some output, some folders with data files here in Amazon. And what we want to do is explore this data, right? So we've got a big bunch of Amazon product reviews. We want to take a look. So if you're wondering what's going on in this cell here, what I wrote just above, that's not actually Spark code. If you'll notice it looks very much like sitting on your Mac or your Linux machine and typing an ls, and that's because that's what it is. I'm just running a shell command, And this %sh is a magic tag that runs a shell command on the back-end machine. So far, no Spark, just looking at some files. Let's go run our first Spark query. So I'm going to do a select star from this chunk of data, and I'm going to tell Spark about it by using this notation parquet dot and a backtick and a file path. And that just gives Spark a hint about the file format that we're using here. So we'll talk a little more about that later. But you can see that I went and ran a plain old SQL statement, the same kind you might run with Oracle or MySQL or whatever database you're using. And I get back a little report on the screen. And you can see I've got a number of stars here under the rating column, like a 4-star product review on Amazon. And then I've got the actual full text of the review. So one of the things we do sometimes in our machine learning classes is we'll use this to build a sentiment analysis model. Sentiment analysis is where we try to predict the tone or the sentiment positivity of a review based on, say, the actual words, right? So this is something a lot of companies do to monitor their interaction with their customers and try to improve their kind of customer response. Here we've got just a little bit of a report, and there's some fine print here showing just the first 1,000 rows. Because you might be thinking, well, Spark is about big data. What if I have, a petabyte of data? Am I going to be trying to look at a petabyte in my browser? That's not really going to work. And of course, you're right. So when we look at this in the browser, we're automatically adding a limit operator onto this query so that there's not so much data coming back. Okay, so we can see a little bit of the data, and maybe we want to build some reports or tell some other folks about it. And so we'd like to create a visualization that summarizes this data. And of course, there's lots of ways to do that. But one thing we might want to do is just say, how many positive reviews do we have here? I mean, are people happy with the products? Are they unhappy? What kind of reviews are we getting? And so if we do a query that pulls up the ratings and counts the reviews by rating, we can use a little embedded graphing widget to generate a graphical report. You can see it just takes a click or two to do that. And by using this plot options button, we can even customize this report. Now, this particular graphing widget is part of the Databricks notebook, but all of those open source notebooks that I mentioned are also compatible with open source graphing. So things like Apache Zeppelin has a graphing widget built in that works just like this. So you don't need to pay anything to get access to these kind of capabilities. Another thing you might be wondering is, hey, I'm a data engineer. This notebook thing is cute, but how do I do this, with my actual, from the command line? How do I do this in my scripts? So if you don't have a %SQL magic around in a notebook, the way that API is going to look is we're going to start out by typing Spark, which is an instance of a thing called Spark Session that allows us to talk to, essentially talk to Spark. We're going to go spark.sql, and we're going to give it a SQL string. And if we put a .show on the end of that, you'll see that we get a nice little report here that looks almost like we're running a command line database client. We get a little ASCII art table. You can see the columns and the data in there. So you can do this without any kind of a notebook. Another thing that you might wonder, whether you're a data engineer or an architect or a team lead, you might say, well, the SQL thing is great for exploring, but I don't want to write my data engineering jobs, or if I'm a lead, I don't want my engineers writing their jobs as a bunch of SQL strings, right? Because there's a lot of things that can go wrong managing libraries of strings. So Spark does have a nice object-oriented API for manipulating these queries. And we're going to look at that in a little bit. But the SQL stuff I wanted to show you because it's really great for interactive analytics. It's easy to get started. You can run your existing SQL or HiveQL reports. So if you have a big investment in HiveQL queries and reporting, like a lot of companies do, you can use those directly with Spark. You don't need Hive. I mean, you can use Hive, but you don't need it there. You can also connect through a JDBC or ODBC reporting tool. So if you have analysts that use something like Tableau to generate reports, and they don't normally ever write code by hand, they can actually talk directly to Spark and generate reports off of your data. And you can do all kinds of nice things linking this stuff together. So before we go any further with code, I want to take a step back. I like to do a little code at the beginning just to make things real, so you're not just hearing a story about, some abstract features. But before we continue with the code, I want to talk a little bit about what Spark is. Let me actually zoom this in just a tiny bit. About what Spark is and roughly how it works. So what is Spark? So Spark is a distributed data parallel compute engine, and it's got a lot of other pieces on there like we've been talking about just to make life easier. But the key pieces are distributed, meaning across lots of machines. And to drill down on that a little bit more, it's not enough to just put work on more than one machine, right? If you don't do it exactly right, you can end up with a situation where you're throwing more and more servers at a problem, but you're not really getting more and more results. So what we want to do is make sure that as we add more servers, our results are scaling linearly with the number of servers. You can think of this as meaning if you multiply the number of servers times x, you should either be able to process the x times as much data, or you should be able to process your original amount of data in 1 over x as much time. So those are kind of two ways of thinking about linear scalability. So that's a really important feature of Spark, and there are many workloads today that run in the tens of thousands of nodes on multiple petabytes all day long. So Spark does scale linearly into tens of thousands of nodes. Spark is a data parallel compute engine. So data parallel is one of the models for doing parallel computation. The idea is that we take our big data set, we describe it as a bunch of separate chunks. In Spark, those are called partitions or blocks. And we run the same code over the different partitions. So for example, if we're trying to find customers in New Jersey out of a trillion customers, well, I guess nobody has a trillion customers, but if you're Facebook, you might have a billion customers. We could take our billion customers, divide them into chunks, and run that operation where we check to see if they're from New Jersey simultaneously over each of those chunks. And the last part is compute engine. So, well, of course it's doing compute, so why do I even put it there? Well, what I'm emphasizing here is that unlike a database, Spark doesn't manage its own storage, right? So many systems that handle queries like this operate their own storage in very clever ways, and that's great. Spark doesn't manage its own storage. Instead, it talks to any kind of storage you have. So Spark will talk to databases like Oracle or Mongo or Cassandra. It'll talk to flat files like CSV or JSON, and it can actually look at all of these at once and even join them and use them in the same query. In terms of file system, it's also very flexible. Your data could be in S3, it could be in HDFS, which is the way it's commonly done on-prem. And while Spark doesn't control how you store your data, it's happy to talk to all of those sources and try and optimize as much as it can. So what is the basic architecture of Spark? So here's kind of a simplified diagram. And it illustrates the three main players in any Spark cluster. The first one is the Spark driver. So the driver in this picture is the green box on the left. The driver is a JVM or Java virtual machine. And the driver is the brains of the whole operation. The driver is the thing that understands your code and your queries. It does all of the scheduling and planning. It does the recovery when there are problems. So your driver is really the brains, and it's just one of those. And it plans all of the work. The next big player are the executors. These are the pink boxes over on the right. Executors are also JVMs or Java virtual machines. And the executors are meant to be dumb and simple and inexpensive. So we can have lots and lots of executors. So when we talk about a 1,000 node Spark cluster, what we really mean is 1,000 executors. And the executors are meant to accept work from the driver and do it. So the executors just do three things. They run tasks that they're told to run by the driver. They can cache data or store it either locally on their node or like on disk or in memory. And they can also trade blocks of data with the other executors in order to do certain operations. So in the data parallel programming paradigm, we have our map operations and our reduce operations. If you're not familiar with that terminology, that's fine. But reduce operations refer to operations where in order to get a final answer, we need some data to move around the cluster. So you could imagine in our example of customers from New Jersey, if we wanted to total up all of the revenue from those customers, right? We could total up the revenue from the New Jersey customers on each executor. But in order to get a grand total for our final report, we need to move those totals together and kind of get a sum across the whole cluster. That's kind of a simple way to think about it. And the executors handle that on their own. The third player here is the cluster manager. That's the blue box in the middle. And the cluster manager doesn't do a whole lot with Spark. The cluster manager is mainly there in order to help Spark's driver start up and acquire executors. And in case executors die, or if we're running in auto scaling mode and we want more executors, the cluster manager helps us acquire additional executors. There's several different cluster managers you can use with Spark, and in some of the longer courses, we get into the details of that. So I have a summary here. This notebook will be available. I'll make it available after the seminar here today, and so you can take a look at some of those details. This kind of sums up what we were talking about, and it lists the available clustering options today. So you can refer back to that. In terms of programming Spark, there are lots of ways to do it. If you download Spark, it comes with an interactive shell in Python, Scala, R, and SQL. You can write scripts. You can also compile programs like Java or Scala programs into regular old jar files and launch those on Spark using a helper called Spark Submit. You can write your code in various languages. Spark has support for SQL, Scala, Python, R, and Java built in. And there are extension projects on the net that allow you to use .NET tools like C# and F#, or even JavaScript if you wanted to. But mainly it's Scala, SQL, Python, and R. Those are probably the predominant ones, and then maybe Java a little bit behind there. And today we'll be using Scala, SQL, and a little bit of Python as well. So let's take a look at a little bit more data. So I have a data set that I mounted up here, which is a list of accesses to Wikipedia. And it actually says here Donald Trump's inauguration, but this data set, that's not actually correct. I realize the data set I grabbed here is from the State of the Union speech. And it's just interesting because when big events happen in the news, like a president gives some big speech, you can see that people go to Wikipedia and start looking up the stuff that that person is talking about. So it's kind of an interesting data set to see what were people searching for when Trump was talking about whatever was going on in that State of the Union speech. So let's see. I have this file here called pageviews.gz, which is analytics data from Wikipedia. So they publish all this stuff for free. You can just go grab it. That's all I did. I put it in an S3 bucket and attached it here. And if we wanted to take a look at that file and we had no idea what was in there and just wanted to see what's inside, we could do something like this. We can say spark.read, which gets us access to a kind of helper for reading in data. And then we're going to say .text, which is the format, because we don't know yet what's inside this file, so we're going to try text. We're going to give it a path, and we're going to say .show, because what we'd like to do is actually run this query and look at a few records. So if we run this query, you can see that we get a bunch of results back, and it looks like we've kind of got a space-delimited data set. I happen to actually know what the schema is here because there's a data dictionary on Wikimedia's site that tells me. But this is how you could take a look at a file really quickly. If you didn't know what was in there, you can just do a spark.read.text. Now, in fact, from looking at the data dictionary on the Wikipedia site, I know that this is a space-delimited file that's basically like a CSV, but again with spaces. I'm going to tell Spark to figure out the schema here on its own. And I'm also going to rename the columns. So this particular data set doesn't have a header row that names the columns, and I happen to know what these columns are called, so I'm going to go and give these columns some names. The first one is the Wikimedia project, like English or French or English books or Wiki Travel. The second one is the name of the page, like main page or United States. The third column is the number of requests to Wikipedia for that page in this particular hour. This data set represents 1 hour. The fourth column used to contain bytes, but it's no longer used, so it's got zeros in it these days. And if we run this, you'll see that we don't actually get an answer on the screen, right? We don't actually get a report here. What we get is an output of a thing called a data frame. And a data frame in Spark is a really interesting thing because it's not an actual chunk of data. It represents a query. And that's actually something it takes people a little bit of time to get used to when they're working with Spark, because in some other tools like R or Pandas, a data frame is a container object that has your data right there. You can go in, look at it, change it. In Spark, a data frame represents a query. So a data frame doesn't actually contain any data. It's just instructions. And we can use a data frame to make other data frames or to eventually create some results. Now, I can use the data frame API directly, and we'll give a demo of that later, but for now, let's just take a quick look with SQL. So the way I can link an arbitrary data source from any of those sources, any file format, and be able to talk to it as if it were a table in Spark, I can do that by going create or replace temp view. So in this example, you can see I'm calling this thing page counts. And now if I come in with SQL and do a describe on page counts, right, you can see the schema here. So you can see that Spark has kind of figured out what the data types are. And then I can write plain old SQL queries. So without any further work, I can just go ahead and say, you know, how many requests were there, say, to the English project. If I want to see the top results, so this is where we get to see what people were searching for during the State of the Union speech, because we'll see the most popular queries during that hour. This is data that Google and Facebook have internally, but they don't share it with us. Wikimedia is kind of interesting because we can get all this stuff. It's public. So here you can see that this was a couple of years ago, but during that speech, you can see there were some Kennedy figures and some other stuff that came up in the context of that speech, and people started searching for it during the actual speech. And maybe we'll do one more, like we can see how popular was Apache Spark among all the pages that contained the word Spark in this hour, you know, I think in early 2017 or so. Let's see. So Apache Spark was number 4, it looks like, you know, after Paul Sparks, Nicholas Sparks, and LaCroix Sparkling Water, which is kind of funny. So if you're wondering what, these are really simple queries I've been doing so far. If you're wondering what kind of SQL dialect is supported here, so there's support for ANSI SQL 2003, so including window functions and other fairly modern SQL. There's also full support for HiveQL. So there's sort of 2 separate interpreters. They're both built directly into Spark. Or I should say parsers, not interpreters. They're built directly into Spark for handling these 2 different SQL dialects. Now, earlier I mentioned that if you're a data engineer, you probably are thinking you don't want to write all of your transform pipelines by creating a bunch of SQL strings. And that makes sense. And if you're a lead, a manager, an architect, you probably don't want your team doing like everything just through SQL strings. So here's kind of a little bit of an intro to what the data frame API looks like. So this is where Spark lets you work with objects that represent things like tables, queries, and columns. So it allows you to programmatically manipulate your data to do more complex things. And it's nothing too crazy. There's a few advanced bits in here. But the basic operations are fairly straightforward. So for example, in SQL, where you would do a select, the data frame API lets you call select or select expressions to select different columns or evaluate expressions from a certain data set. And similarly for various other operations. So the query that we just did, the one that found the most popular pages in that hour with the word Spark, we would write that something like this in the data frame object API. We'd say spark.table page counts dot filter project matches en, another dot filter for page like Spark, and then an order by request descending. And if we run this along with that display that you see underneath, the display says, hey, it's not just a query, I want to actually see some answers here. We should see the first few answers. And what I'm going to do is just kind of take this apart to give you a look step by step at what's going on in here. Just so you can see, like, where does some long expression like this come from? So if we go spark.table page counts, this gives us a query or data frame that kind of represents select star. It kind of represents everything that we connected to that table name page counts. I'm not going to display it here because I want to save a little time. But you can see that what I've done in this next cell is composed several steps. So we're saying, give me everything from page counts. And then we're saying, well, take that and I want you to filter just for the English project. And then we're saying, that's great, but let's take that and let's put another filter on here where the page column, that's what this apostrophe page is doing, contains the word Spark in it. And you can see that each of these, step 1, step 2, and step 3, is effectively its own query. And we're composing these queries together. So we're saying, like I was describing in my narrative, take the first thing and then wrap it in another query with a filter, and then wrap it in another query with another filter. And you might be wondering, well, wait a second, if I'm creating all these queries and nesting and all this, isn't that going to be really messy and inefficient? And the answer is no, because Spark has an optimizer that will restructure your query and clean it up before it actually executes. So just like a database has a query optimizer and a query planner, Spark has a very sophisticated optimizer and query planner that will take this and create a more efficient representation in order to actually move the data around as quickly as possible. So in the longer course, we actually spend almost an entire day learning how Spark actually does this so that we can get the best performance out of the system. So, okay, well, I'm going to cruise past a couple of these details, again, for time reasons, but I put them in here so that when you look at the version, I'll give out, like I said, an HTML version of this notebook that you can look at without, worrying about Spark. After the webinar, you'll be able to kind of take a look and review some of these details. I also made a note about where the documentation lives, because even though we're not going to explore the docs today, usually sometime around this time, once people have seen all the options, sometimes they start getting a little bit anxious. Well, hey, there's so many ways to do this. It sounds really exciting, but how can I learn more about it? So there's great free documentation online under the Apache Spark project. And the places to focus on for data processing are the dataset class, the column class, relational grouped dataset, which is important for aggregations, and this package object down here has this long link called org Apache Spark SQL functions. And that has tons and tons of built-in, very performant functions for doing all sorts of things with your data. So let's see, I'm going to run another query here. And what this is doing is it's grouping the requests by project. So again, English versus English Mobile versus French. And it's counting them. And then it's ordering them. And what this is telling us is, hey, the most requests came into the English desktop project. The next one was English Mobile. Then in this particular hour, Japanese, and Japanese Mobile, Spanish, etc. But I wanted to use this to just give you a tiny look under the hood for just 2 or 3 minutes as to what's kind of going on here, what might be going wrong or going right, that's really important to know about. So my claim here is that this is actually taking too long. It only took 10 seconds, but the point is that this is not working the way it's supposed to. And I don't want to get too much into the detail today, but I want to give you a glimpse of how you could explore this and some of the important tooling that's totally free with Spark for optimizing jobs. So my claim here is that we're not really getting our great cluster computing that we wanted, that we're really only using one thread, and things are not working quite right. And the way Spark runs something like this, all of the queries we're running today are running within a single application, and that application is the one that's handling the requests from my notebook. And we're running a bunch of queries, like we just ran one right there. And when you tell Spark to run a query, it breaks that query up into jobs. The jobs get subdivided into stages, and those stages get divided further into tasks. So again, in the longer course, we explore exactly how all this works because it's fairly important for getting really good performance out of Spark. In the simplest case, the real parallelism across our cluster happens at the task level. So the idea is that if I have 8 cores in my cluster, which I have here, I should be running 8 tasks at a time. And I know we haven't described exactly what a task means, but we certainly should be running 8 of something at the same time. That's the whole point of using Spark. So what I want to do is show you the Spark web UI. So even though I'm opening this up via Databricks, this web UI is 100% free and open source, and you don't need any commercial tool to get access to it. And it's essential in terms of understanding how your jobs are running. And what it allows us to do is to drill down. And I understand that I'm clicking a little bit quickly here. If this is your first time seeing Spark, I don't expect you to have any idea how I'm kind of navigating this, but I want to show you this exists, this great visual reporting tool. And what this is showing, that green line is showing the compute that's going on. And if I had lots of compute going on at once, I'd have lots of lines here in parallel, but there's only one. And what that's telling me is all of my compute is happening in a single task, which means a single thread running on a single core, and the whole rest of my cluster is being wasted. And this is obviously not what we want, right? This is, I could do this on a single machine. I don't need Spark for this. So let's go and just quickly fix this. The issue in this case is that I have one big gzip file. Gzip, just by its own design, it's not made to be split. In other words, it's not meant to be read from multiple places at once for parallel compute, kind of because gzip was invented 20 plus years ago. Well, 30 plus now, I guess. So what I want to do is rewrite this, and I'm just going to do a really simple rewrite. I'm going to say spark.table page counts. That just finds all this page count data we've been playing with. I'm going to say .write because I want to rewrite it to some other destination. And I'm going to say .csv because I'm going to write it out as a plain text CSV just to make it super brain dead simple. And then I've got a path here which actually maps to an S3 bucket. And then what I want to do is see if I can count it from the original data, and then I'm going to count it from the new version, and you hopefully will see that the new version is actually doing 8 tasks at once. We're actually getting our parallelism back. So here is the original count. And I'll also queue up the CSV count. So we're going to get the same answer, right? The whole point of Spark is not that it gives you a different answer, it's that it does things in parallel, right? And if we look at this first job, you can see that there are 2 stages, and the first stage, which is where the reading is happening, is only one task doing all the work. Whereas in the second one, the read stage that's doing the reading and the counting has 8 tasks. And if we flip back over to the UI, we can actually see that. The stage that we're looking at is this one here. And you can see that now we're actually using all of the 8 cores in our cluster. So we're actually scaling stuff out. Now you might think, well, this is a really silly example. This is not, who would actually make a mistake like this? And the truth is, on the one hand, this is not the best example in the world. But on the other hand, I see many, many Spark deployments that are actually running slower than a single server could process the data, if you can believe that. Because if you misconfigure things, you can actually end up in that situation where you'd honestly be better off just using a single machine. Now, that's not always true, but the idea is that if we want to make sure we're doing stuff right and we're getting the most out of our IT investment in terms of people, knowledge, and physical hardware, we do kind of need to dive a little bit underneath the hood. Now I have a few notes in here, kind of about what's going on and about other data formats that we might use, and a few other demos that I will make available for you to review after. But I don't want to spend too much time on this today because we only have about 15-20 minutes left, and so I'm going to skip to the next major topic. So like I said, I will give this notebook out for you to see the results, but I want to skip over to the next major topic, and that's Spark machine learning. So we have a chance to get a quick look at how Spark ML works. So in this example, we're going to again look at a data set that I have here in S3. Here I'm running a head command so you can see what that data looks like. It's a data set from the R kind of universe of a bunch of diamond sales. And for each diamond, we've got properties about that diamond, like the carat weight, the color, the clarity, the shape of the cut. And what we're trying to do here is predict the price. So you can see that for each diamond, we have a price. It's actually in US dollars in this data set, even though it doesn't say it here. And what we'd like to do is kind of take a look and see whether we could use Spark to model the price of a diamond as a function of these other numeric parameters here. We're going to use just the numeric parameters to keep things short and simple for today. Of course, if we were doing this for real or in the longer class, we would make sure we use all of the data available and we could build a better model. So up above, I just did a Linux head command. That's not Spark code. Here I'm going to run a Spark command, and I'm switching over to Python. So Spark allows you to mix languages. And in this case, I'm going to shift to Python because, in the machine learning world, pretty much everyone is using Python or R. And honestly, I don't know very much R. So if I were doing this in R, I wouldn't be very effective. So I'm going to focus on Python here. And this is a similar command to what we did earlier for creating a data frame that's derived from this data file and looking at some of the rows on the screen. So now Spark has access to this data. So for our simple example today, we want to look at the price as a function of the numeric predictors here. So we're going to look at carat weight as a predictor of price. We're also going to look at the other numeric predictors, which are, or some of the other numeric predictors, which are the dimensions X, Y, and Z. So X, Y, and Z are sizes in millimeters of the diamond. And so we're going to grab the carat, the price, and the X, Y, and Z values, and we'll see if we can use those to predict the price. So this is another command that just says, hey, I want a query that pulls up these columns. And if we're doing some data science, we might want to, especially a linear model, we might want to do a scatter plot to see what's going on here. So this is a scatter of carat versus price, just to kind of see how that works. Now, before we can build a model, we need to assemble all of the predictors or features into a single feature vector. So unlike scikit-learn and pandas, where your features or predictors are in separate columns, in Spark, they all have to be in a vector in a single column. And that may change in the future, but at least for now, that's the way it works. So we're going to use a built-in helper called vector assembler to collect the numeric columns together and create a new column called features that contains a vector of these features. So this assembler is a feature engineering or feature processing helper that's built into Spark alongside lots of other feature engineering pieces that help us transform our data to prepare it for modeling. So if you do machine learning, you know that the kind of cliche is that 80% or 90% of your work is actually data cleansing and processing and engineering work before you get the fun part of building the models. And so Spark has a number of tools for that, and this vector assembler is one of those. So I'll show you what the vector assembler does by taking the assembler and calling .transform, because the assembler is a thing called a transformer in a pattern that is modeled after scikit-learn, but doesn't work exactly the same way. So again, in the longer classes, we explain how the API patterns work in Spark in terms of transformers and estimators, how they're similar to other systems like scikit-learn, and how they're different. In this case, I'm using this transformer called a vector assembler to transform my data frame, and that's producing a new data frame that has this features column over on the right. So if you see on the right here, there's a column called features, and it has a vector full of double values. Spark always does its machine learning modeling over vectors of doubles. Okay, well, we have a feature vector here, so let's grab a linear regression algorithm. We can go and instantiate that and tell it that what we're trying to predict, the label, lives in a column called price. And then we're ready, almost ready to do our modeling. We want to do a training test split because we want to make sure that we have some held out test data to use to see whether our model is any good. If we don't hold any data out, we'll never be able to tell whether our model generalizes or not. So I'm going to use a built-in helper called random split to create a training and a test set. Then I'm going to add the vector column to the training set, and I'm going to take the linear regression and fit it against that data, and that's going to give me a linear regression model. And then to make predictions, which I'm going to do on the test data, I'm going to take that linear regression model, and in Spark, all models are actually transformers, and I'm going to transform the vectorized test set here. So now what we should get is a model and then a set of predictions. So here you can see that I've got an output data frame that has a prediction column. It looks like some of these predictions are maybe not that great, like a negative $29, but in any case, we've now built a model on Spark and we've used it to make predictions. So it's a little different from what you might be used to if you usually use, say, scikit-learn or R or something like that. But you can also see it's not too hard, right? It only took us 4 or 5 lines of code to start creating a model, and then from here we could refine it and try and build something better for the business. Now, one thing you may have noticed in there that was a little awkward is how I had to kind of process the training set and then process the test set, and I kind of had to nest these calls, and you might imagine that that could get kind of awkward if I had 20 or 30 feature engineering steps, which is not uncommon. And so Spark includes another abstraction which is borrowed from the scikit-learn world called a pipeline. And the pipeline's even easier to use. The reason I didn't show you to you before is because I wanted to give you a little bit of a look at kind of the basics, what's going on under the hood. But the easier way to do this in general is to create a pipeline that tells Spark what stages you'd like to use, in this case, a vector assembler, then a linear regression. And because all of the Spark transformers and estimators work exactly the same way, Spark knows what to do with those things. And it allows us to say pipeline.fit, and Spark knows what to do with the assembler, namely to transform the data, and what to do with the linear regressor, namely to do a fit, in order to produce a pipeline model. So pipelines, which are themselves estimators, are kind of an encapsulation of a series of feature engineering and model fitting tasks. So now I have a pipeline model, and I can do a slightly simpler version of model.transform to generate predictions. Let's see. I thought it might be nice to see a histogram of the errors. So what I've done here is I've said, let's take my predictions data frame, Let's downsample it because, again, like in general, I might have a lot of data and it might not be evenly distributed. I want to downsample it to a small number of records that I can use for graphing, and I want to make sure I've got coverage across the whole data set. So I'm going to downsample it, in this case, to 4% or so. And then I'm going to say select expression. I'm going to say I want the price minus the prediction. So that's the difference between the real world and the model's view of the world. I'm going to call that thing error. And then I want to see a histogram of the errors, right? That's pretty important for getting an idea of how our model's behaving. So we get this nice graph, and it shows that, our model's not too bad. It's kind of interesting. It tends to make a few more errors on the low side, it looks like. If I wanted to get a statistical measure of how well our model did, I would create an evaluator. So Spark has these evaluators for different kinds of tasks. Since this is a regression task where we're predicting a continuous value, I'm going to use a regression evaluator from PySpark ML evaluation. And once I have that evaluator, I can say .evaluate and give it the data frame with the predictions. And Spark tells me, hey, the answer is 1548. To which I say, whoa, wait a sec, 1548 what? And we can use some online help here to see that the default metric name, not the only one we can use, but the default here is root mean square error. So what I've got here is an RMSE of 1548 in my test set. And if I use a dataframe.describe, I can see the standard deviation in the price data was almost $4,000. So 1548, while it's not great, I've definitely learned something. So the machine learning here is definitely working, right? I've reduced an error that would have been around 4,000 down to 1,500. So that's great, although it's probably not good enough for the new diamond business I'm going to start up in time for the holidays. So if we had more time, we could try some fancier algorithms and get that error much smaller. So, okay, so we've taken a quick look at Spark machine learning. We haven't really, there's a few things we haven't touched on. More complex data preparation. I've got a typo in here, which I can fix and demonstrate the markdown at the same time. You can see I switched to markdown mode and then back to rendered mode. So we might want to do more complex data prep and pre-processing, like de-skewing and encoding categorical variables. It would be nice to play with other algorithms if we had more time. We would look at things like tuning and cross-validation of models, how to combine Spark with other tools like scikit-learn and TensorFlow, because that's really important. Not everything in the world is going to just be inside Spark. We want it to work in a performant manner with other tools. How Spark actually does these model building jobs in parallel, and how to extend Spark ML. So Spark ML is meant for you to extend if you want to with your own feature engineering transformers and estimators and even your own algorithms. So it's not a closed box. You don't need to hack on Spark code. You can kind of plug directly on and add your own pieces. So we've got about 5 or 6 minutes left, and I want to use that just to give you a very quick look at one of the areas of the most recent development in Spark, and that's structured streaming. So this is a way of looking at streaming apps as if they are just tables that keep growing. It makes it much easier to think about streaming because you just think about it as an append-only table, and you can use all of the stuff that you've learned and built for data frames and SQL to work over streaming data. In this example, we're going to look at real-time edits, like actually real-time right now, into Wikipedia. And we're going to kind of take a look at who's editing the Wikipedia in which languages. So this first command, again, there's no Spark here. This is just showing you what the data stream looks like. You can see that it's JSON encoded, and it has a bunch of information about each edit. So like what language and where the edit's coming from, obviously what article is being edited, who did it, and so on. I'm going to make a little tuning adjustment to Spark here because there's not that much data in this stream. So I want to kind of change the parallelism a little bit. And then what I want to do is write our first streaming program. And it's very straightforward. It's modeled on the data frame pattern, but instead of saying spark.read, I say spark.read stream. In this case, I'm reading from a socket. That socket is providing data from this particular host and port. And then I need to parse the JSON. So I'm going to do a select. I'm going to use a built-in function called JSON tuple to decode the value column that contains the JSON and extract these other columns from it. So channel, which is the language, timestamp, is robot, and is anonymous. And when I run this, you can see that I actually get a plain old data frame out. So the system is really unified underneath, and we really do view this data as a data frame. It's all one big system. If I call display on this, we'll be able to see these updating in real time. See, if I hover over the squiggly line here, you can see what it's doing. It's processing data, and now I've actually got a bunch of edit data streaming in here. And every time it gets more data, it's kind of updating the view on the screen. So I'm going to stop that. And I want to show something a little bit more complex that's also maybe a little more useful. So we wanted to count the edits that are coming through in the different languages and kind of compare those. So I have an example that does that. I've got a couple examples. We only have time for the first one, but I think that will give you an idea. I'm going to read the data the same way I just did. I'm going to decode it the same way I just did. I'm going to adjust the columns a little bit, like I'm going to give them some nice names, and I'm going to convert the timestamp column, which is originally a JSON string, into an actual Unix timestamp. And I'm going to give it a table name called edits. And there's a demo that we can combine all these things. I'm going to use spark.sql to do a regular SQL query that counts the edits and groups them by channel and time. And then I'm going to write these out to a buffer so that we can take a look at what's happening. So at this point, we have data flowing through the system. We can't see it because we're writing it to a buffer, but what I can do is I can query the table that I created above, which is called demo. And whenever I adjust this or refresh this, you'll be able to see the very latest data coming through. So this is showing the number of edits at each of these 1 second timestamps across the different languages. Now, if we had more time, the next example that I would do would be to look at how we can kind of bucket these over wider time intervals. Because when you look at this, there's a lot of noise in there, right? We're comparing edit counts per second. And that's maybe a silly way to do it. So in real life, we probably want to look at edits every 10 seconds or every minute. So if we had more time, that's what we would do. We don't have more time today, so I'm not going to. But I'm going to turn off this streaming job. And the very last thing I'm going to mention here is that with Spark 2.3, for the first time in the history of Spark, we have a low latency or millisecond latency continuous streaming mode. Historically, Spark did streaming only in micro batches, which is actually really great for a lot of applications. But Spark also supports continuous processing now with millisecond latency, which is key for a lot of business use cases. So to wrap up, we've gotten kind of a tour of all the major areas of Spark and some of the tooling here. And the common use cases for Spark for most businesses are batch ETL jobs, batch or ad hoc analytics, data visualization, building machine learning and scoring data using machine learning models, streaming applications that combine all of these. You can have streaming ETL, machine learning, or analytics apps, and also graph analysis using some other add-on APIs that we haven't seen today, all with high performance and linear scalability. So that's pretty much all we have time for today. I hope this is useful for everyone as an overview. Got about 2 minutes left. If you have any questions and you want to pop them up into the chat, I'll see what we can fit in here.
Perfect. Thanks, Adam. I know we're almost at the hour, but I definitely appreciate you sharing this information. And in the chat bar, I did add if anyone has any questions to please feel free to ask them if you have any pressing questions that you'd like, or burning questions, I should say. You'll also receive a follow-up. So everybody who registered and attended today, will be sharing some information, a recorded version of the session that you saw today. Also, Adam has some resources that he'll be sharing as well, so we'll include that in our follow-up communication. Another important thing is that we're going to be including a post session survey, just to ask a little bit about how useful this information was for you, the format. I think, Adam definitely took some time to make sure that this is a little bit more hands-on, our show and tell, if you will, in regards to actual utilization of Apache Spark in the real world. So, we'd love your feedback in regards to, upcoming sessions and if the format worked for you. So, with that said, I think we're at noon, and then what we'll do is we'll gather all the questions and we can answer those as well in the follow-up email that will be coming out tomorrow. So, Adam, I want to thank you tremendously for this presentation. I think it's really good information, and like I said, I really enjoyed the presentation and the way that you went through the actual notebook itself. If there's any other questions, again, please feel free to reach out. Any final comments, Adam, or suggestions?
If you haven't used Spark or you haven't used it in a while, take a look at the latest. Take a look at the latest documentation. The latest release of Spark is 2.4. It just came out about a month ago. Lots of exciting brand new features. With each new version, there are ways to get the programs you're running at your business to run faster and easier, and we're happy to help you do that.
Absolutely. If there's anything that we can help with, please feel free to reach out to us. connect@endpointlearning.com. Once again, thank you all for joining. Adam, thank you again for the presentation, and we look forward to seeing everybody in the future.
Great, thank you.